When the Centrifan PE is paired with one or more Rotorvaps, the operators can process more samples through the Rotorvap because the tricky final drying steps are accomplished by the Centrifan PE with no operator involvement. The Rotorvap sample shown here is simulating a natural product extract in methanol. The common procedure is to dry this down to about 10 mLs, at which point the liquid will be taken from the round bottom flask on the Rotorvap and transferred to a 20 ml scintillation vial. To recover as much sample as possible, even at the expense of some re-dilution, the round bottom is typically rinsed with solvent and this last aliquot also transferred to the scintillation vial. Now the vial is attached to a special adapter which allows the vial to be mounted to the neck of the Rotorvap. In this way, the vial is substituted for the original round bottom flask, and the drying process can continue with the sample already in the final storage container. Because even the remaining 10 ml sample is large relative to the small size of the scintillation vial, the operator has to be very careful to apply the vacuum slowly so that the sample doesn't bump or foam and get lost in the Rotorvap glassware. So the response to a bumping event such as this is probably disassembly and rinsing of Rotorvap glassware. Now your sample is effectively re-diluted, and you may even have to back up to a round bottom again to re-evaporate to 10 mils. So fortunately for us, in this video clip, it's simply a matter of pressing rewind to give ourselves the opportunity to consider an alternative to using the Rotorvap itself to process the last bit of liquid going into a 20 ml scintillation vial. Boy, can you imagine having a capability like this that would back up time and undo mistakes? So since that's not possible, let's talk about a companion device to a Rotorvap that might help us avoid the mistake altogether. This product is called the Centrifan PE. It uses a fan to produce a self-generating blow-down gas flow. There is no vacuum involved here, so there's no danger of bumping. There are several rotors available. The one shown here holds 6 20 ml scintillation vials. You add the gas flow splitter. It's a device that prevents turbulence at the entrance to the vials. Add the cover, close the lid, and it starts the fan spinning. The vials sit in a rotor which is installed in the center of the fan. The spinning motion generates centrifugal force and keeps your sample absolutely safe. There's no danger of bumping, no danger of sample loss or contamination. So the vial we just added to the rotor contains about 10 mils of methanol at 40 degrees C. Will take about an hour to evaporate. Let's see what else we can accomplish during this hour that we're not babysitting the vacuum on our Rotorvap to keep our scintillation vial from bumping. Since the Rotorvap has been freed up by the Centrifan PE, we can continue to use it for its designed purpose, that is to evaporate large volumes of liquid in round bottom flasks. Instead of the operator applying his time to the careful evaporation of a 20 ml scintillation vial, he can power through 200 or 300 mils of methanol in the Rotorvap system that the Centrifan PE has made available. Once again, through the magic of video, let's jump ahead an hour and see what sort of progress the Centrifan has made on the samples as we've continued to evaporate the large volumes of liquid on the Rotorvap. Checking the drying progress of the vials is a simple matter of just opening the lid. There is no vacuum to release. Take the cover off the rotor and you have immediate access to the vials. The Centrifan PE, by offloading the labor-intensive final drying steps, can increase the throughput and hence the productivity of several Rotorvap systems. Because there is no vacuum used, the Centrifan is simple, rugged, requires only occasional cleaning for maintenance, and has a 3-year warranty on all labor and material defects except the breakable cold trap.